Okay, so this is like the second topic for section 3.4, which is solving equations that have radical expressions in them. This first example, number one here, I chose because it has the simplest situation of a radical equaling a plain number. So the problem is square root of 3x minus 4 equaling 1. Um, the principle behind what we're doing here is you might call opposite operations or inverse operations. The inverse of a square root is squaring. So that's the operation you apply, which I've done in green here. If you do this process, you will sort of cancel out, if you like, the square root, which is definitely progress. We now just have a simple equation left over, a linear equation on top of that. 3x minus 4 equals 1. And you just proceed down the normal algebra way to get 5/3. It's even more important to check these answers here. It's not even optional anymore because it can often happen that what's called an extraneous solution might come up. Extraneous solution, which means your algebra work could be just fine, but it just happens. It just happens that the number you got will not work in the original equation. So you've got to check it. So I'm going to take that 5/3, and in red here, I'm checking to make sure that if I put in 5/3 for x, does the left side equal the right side? That's all I'm checking. That's the way I do my check steps. Sure enough, it comes out to the both sides balance the same, so we're good. So very simple procedure. If you have a simple radical equaling number, square both sides and go from there. It's very, very straightforward. A more complicated situation comes up in example 2, where we have radical x plus 4 plus 2 equals x. Now, to really begin this process, you need to have the radical by itself on one side of the equal sign. And so therefore in this example what I need to do is subtract 2 from both sides so that we have the radical isolated on the left side of this equation. And proceed to square both sides like we did with the first example. The left side simplifies really nicely. The right side, though, is a little more complicated. That's just the way it's going to work out. It sure smells like we have a quadratic going on here. So keep in mind, if you have x squared, x cubed, or whatever, you want to get all the terms over to the right side or left side together, and the whole thing equaling 0. You got to set equal to 0, which I've done. And it turns out that we live in this nice world where nothing too complicated was required because, greatest common factor was perfectly fine here. We did not need to use a quadratic formula, anything like that. So there we are. We have these, these two numbers equaling 0. Therefore, either the 1x equals 0 or the x minus 5 equals 0. Solve separately. And then the check step is crucial. If I put in 0 for x, back up in the original equation, way up top here, so 0 for x, 0 for x, which is the first line of the check step, and then simplify and keep simplifying, the left side ends up equaling 4, the right side 0, that's a problem. What that tells us is x equals 0 is not a solution, which is why I had x'd it out very prominently there. Well, we also have to test 5, okay? So I'm putting in 5 for x here, 5 on the right side, making sure does the left side equal right side. It does, so 5 is good. As far as I know, there's no good predictable pattern. Will one of the solutions not work? Both of them? None of them? Etc. As far as I've ever seen or read or experienced, anything could happen. So you just have to check them all. So it's that simple. And it's true the book has a more complicated type of radical situation where you would have two radicals in an equation, and I decided to not include that because I don't think that was really all that necessary for later work. We would be covering enough by the two types of radical equations we've done in these examples, and I think that will complete the videos for chapter 3.4. Like I've done with the other video sets, I'll scan into PDF files these problems I've written out and include them with the video links on Canvas in the modules. All right, thanks a lot.